Hello, I'm Professor Servos, one of your instructors for 1026 this term, and in this video we're going to be going over some of the inputs and outputs that we consider valid for assignment 1. There have been a few questions about this, and we also know some of you can't run those executables, so this video will give you another opportunity to see those executables running, as well as provide some more information about what is valid and invalid input. Okay, before we get into the outputs of the program, I'm going to talk a little bit about the formatting. So the first thing you'll see in the output that I have on the screen right now is this little header that says Project 1, Part A, Fibonacci Sequence. And I know the assignment directions as well as the example executable display this in a few different formats. The formatting of this line doesn't matter so long as it contains this information. So it should say Project 1, Part A. However you say that is fine. The autograder will mostly ignore this line as long as you have the bare bones information that you need. The footer at the bottom is also important, but the formatting doesn't have to be exact. So the end Project 1 Part A should be there in your code. It should say what project it is as well as what part it is, but the exact formatting won't matter. The autograder won't take the formatting of that line into consideration. The very last line should be outputting your personal information. So this should be your full name, followed by your username at Western, the same username you used to log into OWL, and then lastly your student number. So that should be in that same order: full name, first name, last name, your username, and then your student number. So if you're wondering what those numbers are, that's a fake student number, a fake username, and one of our instructors' names. So make sure that you don't put out Max as the output unless that's your name. Make sure it's your actual name, your actual username, and your actual student number. The autograder will check that that information is there, so please include it. So to summarize, the formatting of the Project 1, Part A, Part B, Part C, whatever lines, doesn't have to be exact. It doesn't matter if they're circular brackets, triangular brackets, curly brackets, whatever you want to use. It should be in your program, but it doesn't have to exactly match what's shown in the executable or in the assignment, because there were some differences there. You should include your full name, your username, and your student number as the last line of output, and everything else that's output should follow what the actual assignment description explains. So for part 1, question A, this was the Fibonacci sequence. We consider any number that is an integer value, that's a whole number, no decimal places, and positive to be valid input. Remember, you don't have to check for or correct invalid input in this question, but you only have to ensure that your program works for valid input. So let's take a look at the program. So here we have the example executable. And the point of this was just to give you a more interactive view of what the input and output is that we expect for these programs. You can complete the assignment fine without these. They were just another example. The assignment document does have screenshots as well. So for example, we are being asked for input, and that input is when the sequence ends at. So the Fibonacci sequence is defined in the assignment document, and it has a number of different terms in a sequence. So the user is inputting what sequence, or what term rather, that sequence should end at. So for example, if we input a 5, it outputs the first 5 terms. Well, technically 6, because there's also 0 there. Now, a common error students make is they look at the screenshots in the assignment document, and they assume that because the example showed 20, they can just hard code their solution to 20. Remember that 20 terms that it's showing in the assignment document is because the user actually input 20, like this, and hit enter. So you should be asking the user for input, which is the term that it should end at. Also notice here that once those numbers in the third column start getting over 1,000, or into the thousands and above, they have to have a comma. So let's run it again and get a better example of that. Okay, so now we're going to try it for, let's say, 35. And you can see once the numbers start getting big, we do need commas in that third column. That is the point of the third column. They should have commas. The second column should be the same number, but without commas. So the other type of inputs we should talk about here are those when we start getting towards the edge case. That would be close to the 0. Remember, 0, 1, 2, so on, are also valid inputs here. So because of the way the assignment is worded, it's a bit ambiguous. We say you could hard code those first few terms. So we will allow a few different outputs here. So you can either do it like the EXE does. So for example, if I were to put in a 1 in the EXE, it's going to output the first 3 terms, starting from 0. So term 0, term 1, and term 2. So you could code it like that, where any of those outputs, 0, 1, or 2, will give the first 3 outputs. Or you could code it a little bit more correctly, so it shows the exact right number of terms. Let's see what that would look like. Okay, so in this example, we are going to show what the output would be if you're outputting it exactly with the correct number of terms. So in this case, a 0 would give you the 0 term. A 1 would give you the 0 and 1 term. And a 2 would give you the 0, 1, or 2. So to repeat again, those are both valid for this assignment. You can either have 0, 1, or 2 output all the terms, 0, 1, and 2, or you can have it give the exactly correct term. For any other valid input, it should give you the up to the term the user input. The other thing I will note, stop there. The other thing I'll note when we're looking at this executable is if we put in a really large number, let's say 100, you'll see that the values start becoming negative. So the reason for this is a bug in the executable, and it comes from this executable being created in C and not Python. C is a little bit more difficult to code in, and sometimes when you have really large numbers, you get something called integer overflow. This basically means the computer ran out of memory to store that number, so it flipped it over and started again from a negative number. Luckily for us, Python manages a lot of this for us behind the scenes, so we don't have to worry about that bug. And of course, that bug shouldn't be present in your code. So for example, when we run this in a Python program, if we have an input such as 100, we should get the correct results, as we don't have to deal with things like those overflows. However, if the number is ridiculously big, we will start running into issues like the program not finishing in time, as well as the output starting to look nonsensical because it's just taking up so much of the screen. So for our purposes, we can say that we expect the user to put in a value between 0 and 100. You don't have to account for these massive values that might take forever to print, for example. Okay, on to program B. And for program B, we were calculating prime numbers between 2 values that the user input. So the valid input would be 2 integer values, one that represents the starting number and one that represents the ending number. Now, originally we said that these could be negative values, because that does make sense. If you gave, for example, a negative starting value and a positive ending value, you could check if there were negative primes. They're not, so nothing would be output there, but then you'd get into the positive numbers and should output the positive values. However, since some students were confused by this, and I believe the EXE you were given doesn't handle that case correctly, we are changing this to say that only positive numbers are valid input. Remember, in this case, you don't have to check if the input is valid. You don't have to check that it's an integer. You don't have to check that it's a positive number. You can just assume that that input was correct. For this program, the only thing you do need to check is that the numbers are put in the correct order. So if the user puts in a higher value for the starting value than the ending value, you have to output a message and then flip those values. So let's take a look at an example of what this might look like. So here we can see it's asking for the starting number. As for this example, we'll do something simple like a 1, and we'll say the ending number is 10. So it has to go through all of those numbers, 1 to 10, check if they're prime, and only if they're prime, output the value. Let's take a look at another example. So in this case, let's switch those values around. So let's say the user puts in a 10 first, and they put in an ending value of 1. So in this case, you'll notice that we get a message saying the values have been switched, incorrect input, 10 is greater than 1. So this is the only really input checking you're going to have to do for this assignment. And then you switch those values around and give the output as if the values were put in the correct order. So here you can see we get the values 2, 3, 5, and 7, which are the prime numbers between 1 and 10. Okay, let's take a look at another example. In this case, we're going to say we're starting at 2, and we're going to end at 7. In this case, what I wanted to show you is that these numbers are inclusive. So because we started at 2, we get 2 as prime, and because we end at 7, we get 7 as prime, and we get the other primes between 2 and 7. So those numbers are inclusive. The other thing to be aware of is these numbers can be quite large. So we could have, for example, 1, 2, 3, 4, 5, and an ending number of 1, 2, 3, let's say 70. And we find the 1 prime in that range. So keep in mind these can be large numbers, but they won't be negative necessarily. Okay, so now we're going to give an example of what this should look like with negative numbers, what the correct output would be. But remember, you're not being marked on negative numbers. So if your program can't handle negative numbers for this, that's completely fine. But this is just an example of what the output should be. So for example, if we did negative 10 to 10, we would still get the numbers 2 to 7 because there are no negative primes, at least for our purposes. So the numbers negative 10 all the way up to 0 are pretty much ignored. And then we get 2, 3, 5, 7, which are the positive primes from 0 to 10. So that's what it should look like, the output. I know the executable doesn't handle that negative case correctly, but you're not expected to handle that case correctly either. Okay, now let's take a look at program C. And this was the Moore's Law program, where we're trying to predict the number of transistors and flops for certain years. So there's a few inputs for this case. The first one is the starting number of transistors. Again, this is going to be an integer value, a whole number, and we can safely assume that the user is inputting a positive number. Same thing for starting year, it's an integer value, and we can assume it's a positive number. And the same thing for number of years, it's an integer value, and we can assume that's going to be a positive number as well. So all of these you can assume are going to be greater than or equal to 0. That means you don't have to do any error checking for those other cases. You don't have to check if it's a string or a floating point number. You can assume the user inputted a positive number and that it is a whole integer value. So let's take a look at some of those outputs. Okay, so let's start with the example given in the assignment document. So that was, starting number is 2,300 transistors. We'll say the starting year is 1971, and we're going to run this for 40 years. So here we can see the output. We're starting in year 1971, which is our starting year, so that's inclusive. And we're starting with 2,300 transistors. So again, inclusive. Then we convert that to kiloflops. And then we do this for every 2 years. So since we started at 1971, the next one's 1973, then 1975, and so on, all the way up to 2011. So in this case, we get up to 2011 because that is 40 years after 1971. Let's take a look at another run of this program. Okay, so now we're going to take a look at an example with slightly different inputs. So we're going to give the same number of starting transistors. And this time we're going to say the year starts at 1970, and we'll go for another 40 years. So you can see now the values are basically the same as the last example, except there now our starting year is 1970, and we run up to 2010. So a few things to note. Note that the number of transistors here have commas in it, as does this value over here. So please make sure that these two columns do have the commas in them. Okay, let's give that another try. This time, we'll take a look at a case where the years don't work out quite as nicely. The same number of transistors, same starting year, but this time we're going to say 41 years will be the total number of years to calculate for. And this should look like almost the exact same output as when we ran it the first time. But in this case, we are getting the same output because we said 41 years, and the output is only for every other year. The reason why is because we're saying it doubles every 2 years. So we don't get an extra year here because 41 years would only get us to 2012, but that wouldn't be the next doubling. So we always sort of round down. If we took a look again and ran this again with 42, let's take a look at what happens. Okay, let's try again with 42 years. So same number of transistors, same starting year, and let's go up to 42. So now you can see we get that extra year because it's actually ending on a year where it doubles. So years where it doesn't double, they shouldn't be included in the output. That's why it jumps every few years. Keep in mind, this isn't just outputting odd years or even years, it's based on the starting year. Okay, this time I'll start with one transistor. The starting year, we'll say it's 2020, and we'll do it for 100 years. So you can see we get a lot more output this time because we have a wider range of years. And you can see as these numbers get higher, we do add the commas to it. So make sure in your program, once they're over 999, that you start adding commas in the correct place. Also notice that the value in the center, the flops, like in kiloflops or megaflops, is always converted to the correct unit. When it's low like this, it's just flops, then kiloflops, then megaflops, gigaflops, teraflops, petaflops, and so on. There's a chart in the assignment of all those different values. Note that the example exe does break eventually for that issue with overflowing, but you shouldn't encounter that in Python, so your program should be able to work up to the Yoda byte level. So there is one more case to talk about for this program, and that is when the starting number of transistors is 0. Say the year is 1980, doesn't really matter. Number of years, let's say 100. You can see everything is just 0. And that's correct, because if you double 0, you still get 0. So 0 is valid input, but you just get zeros out. We're probably not going to test for that one, so you can assume the user is going to put anything that makes sense into this program. That'd be a positive integer number. That's probably not 0. So the last thing you have to keep in mind is that there is a part 2 of assignment 1, and that asks you to read the academic dishonesty document and answer a few questions based on it. So make sure you read the assignment document carefully and answer all of the questions it asks of you. To get the full marks for that part, you do need to answer all the questions about that assignment or academic dishonesty document, and you have to answer them correctly. Some of them will be based specifically on your student number. So please make sure you read that carefully and ask if you have any questions. Now there are some rules about the file format for that solution that you're going to have to submit, and that has to be in a PDF document. So your code from the previous part 1, it should be as a .py file, so you should be submitting your .py files for part 1a, b, and c to write to Gradescope, but for part 2, that has to be a PDF document. So you can't submit a Word document or Google Docs or anything like that. It has to be a PDF document. It's important to note here that simply changing the file extension on a file doesn't convert the file, so you do actually have to make sure that you export whatever program you're using to write the document as a PDF. And a good policy is to always test the files you've uploaded. So if you make a PDF, actually check that you can open it. Check that it makes sense, check that it contains what you think it contains. So let's take a look at how you could create a PDF in Word. Okay, so right now on the screen I have Microsoft Word up. You can use any program you like to create the PDF. I recommend Microsoft Word because it works on both Windows and Mac OS, and all Western students have free access to Microsoft Office. So to make the PDF, you go File, you go down to Export, and you click Create PDF/XPS Document. Click on Create PDF. Make sure it ends in .pdf here, and the save type is PDF, and you click Publish. And it will even open up the PDF for you after it's published, and that .pdf file will be the one that you submit to Gradescope. Make sure you submit the .pdf file that you exported. Don't just change the file type on some other file, and make sure that you actually test it and try opening the PDF to confirm that it actually is a legitimate file and it was exported correctly. If you submit a corrupted file, unfortunately you will get 0. So I highly recommend trying to download any files you upload again from Gradescope and make sure that they actually are correct. Don't just assume that it exported correctly. So that's all I have for you in this video. If you have any questions about the file formats, the outputs, the inputs, anything like that for this assignment, please feel free to post on the course forums. That's the fastest way to get your answers. You could also email your course instructor or make an office hour with them. And of course, all of our TAs are available to help you in their lab sessions. Thank you for watching and have a great day.